the question has to be raised, as it should be raised whenever an evolutionary sequence is mentioned. What are exactly the predicted properties one would expect to find as one passes from a land-dwelling creature to a sea-dwelling creature? Specifically, how many changes are required to go from a creature such as Ambulocetus natans, which seemed to have been a land-dwelling creature, to a creature that spends the entire portion of its life in the ocean? Curiously enough, this is not a question that evolutionary biologists ask a whole lot. I did some back of the envelope calculations myself, and the most modest estimate I could come up with is that an organism requires roughly 50,000 morphological changes to adapt itself to the open-going ocean. And as soon as we introduce a quantitative estimate, however loose, however flabby, however spontaneous, then a great deal of puzzlement starts to intrude into the otherwise sunny picture. 50,000 changes, and we've got 2 members of a sequence. Where are the other 49,999 members of that sequence if Darwinian changes are incremental and they're small? After all, we're not talking about changes that are arbitrary. A creature must have these changes if it's to survive in the open ocean. And any attempt to put a quantitative number should induce a profound sense of perplexity, because the number of changes are so much greater than anything we see in the transitional record. Now, what is the proper explanation for this? Please understand, I don't have it. But neither do the other guys. Neither do the other guys. And in my opinion, they refuse to recognize the legitimacy of the question. That is a fundamental question in paleontology. How many changes are required? Can those changes be compared to the fossil record? And if they are compared to the fossil record, why do we see such deficiencies in the record as compared to the necessary changes? Very important issues.